Good evening. Hope you're enjoying this warm August weather. That noise you hear in the background is actually my air conditioner. Yes, I have my air conditioner on in mid-August. Or mid-October, excuse me. Don't judge me. Anyways, I wanted to talk to you guys a bit about taking recursive formulas and writing explicit equations or formulas from them. Now, you guys have been doing some really tough stuff recently, and you've learned how to write some really tough functions. So I'm just going to tell you how you can take these things to the next step. Alright, so I'm going to take a look at number 12 here. Now, I'm getting a little bit of information here. You'll notice I'm given an input for my function and an output. So I know when I put 1 in, 4 is going to come out. They're giving me something here for my second part. F of n equals 3f n minus 1. Now, don't let the terminology throw you off here. Don't let all this crazy stuff throw you off. You can do this. All I'm going to do is I'm going to break this up a little bit. I'm just going to write f of n equals, now, if 3 is next to a variable, anytime you see a number next to a variable in algebra, it's going to mean multiplication. So all I'm going to do is I'm going to rewrite this. Now, hopefully something is jumping out at you. Hopefully something looks familiar. It's f of n minus 1. F of n minus 1. We've been using this a lot for recursive formulas. If you remember, for recursive expressions, we kept writing previous value. And then we decided, okay, we're going to take the next step, the function notation, and change it to f of n minus 1, f of x minus 1, whatever variable we want to use. So that means previous value. So it's telling me within this given function, to get to the next value, I'm going to take the previous one, and I'm going to multiply it by 3. Now, luckily, they give us a little bit more information. And let's see, can I shrink this? Nice. They tell me I get an input here of 1 and output of 4. So what I'm going to do next is I'm going to make a table. It's always good to make some sort of representation. Some people like graphs, I like tables. I'll leave a little bit of space here. I know when 1 goes in, 4 comes out. And I also know, based on my recursive formula here, I multiply by 3 to get to my next term. So, if I multiply by 3, that'll get me to 12 here. So 2 goes in, 12 comes out. To get to my next output, I'm going to multiply by 3. 3 goes in, 36 comes out. Alright, I am almost there. Now, I have to write an explicit formula for this. Or an explicit function, something explicit here. So, I'm going to start out with what I'm looking for. I'm trying to get to f of x, or f of n. Should be using n instead. Not a big deal. That's the thing in algebra. Sometimes you're going to use some different variables. Don't let that throw you off. Alright, so I'm just going to shrink this down a little bit. Alright, so now I've got f of n. Now, for my explicit formulas, I remember I need an initial value to start things out with. Now, hopefully your vocab's kicking in, because that initial value is when I have an input of 0. My table does not have that. I'm going to have to work a little bit here. So if my input's 0, what's going to be my output? Now I know going forward, I have to multiply by 3. To go backwards, I'm going to use inverse operations. I'm going to divide by 3. Now people are thinking, oh boy, decimals. Don't need to do a decimal. 4 over 3. A fraction, the lazy person's division problem. You don't want to solve a division problem? Make it a fraction. Alright, so I got an initial value of 4 over 3. Now, for an explicit formula, I also need to know, what's my change? How am I getting ahead here? To get to the next value here, I have to multiply by 3. So, times 3. And since this is geometric, which means it's dealing with multiplication, it's a geometric sequence, it's also an exponential function, which means I need an exponent for my input. I've got myself a nice explicit function here, explicit formula. Alright, so to recap, when you see something like this, they're going to give you an input here, and then they're going to give you an output. That gives you some place to start. F of n minus 1, f of x minus 1, f of a minus 1, doesn't matter the variable, that means previous value. And then whatever's around it is what's happening to it. In this case, we have variable next to it. Remember, a coefficient. When you have a coefficient involved, which is a number next to a variable. I hate to say next to, because we want to imply operations. But when you have number next to a variable, that means multiplication's happening. So that means 3 times the previous value. Hopefully this helps, and you can do some other ones. And I'll tell you what, we'll do one more of these. What the heck? We'll do the one right below here. People see fractions, they flip out. Don't worry. Fractions are your friend. Again, they're just a lazy person's division problem. Someone didn't want to solve a division problem, they made a fraction. Alright, let's see. Oh, they give me my formula first this time. But they also give me an input and output. I like that. Input 1, output 5 over 3. And they're using n again, so I'm just going to go with n here again. Variables don't really matter. You can use whatever you want. Alright, so now let's take a look at our formula here. Alright, I'm going to break it up. 4 times f of n minus 1. That means 4 times my previous value. That means to get to my next value, I gotta do times 4. And I know 4 is a whole number. I can just make it a fraction, put it over 1, multiply straight across, put in 2, I get 20 over 3. And I can continue and so on, but what I really want here is my explicit formula or an explicit function. So, let's see. In order to do that, hopefully remember, I need an initial value. Which means, what am I starting with? My input is 0. Let's see. Going forward, I have to multiply by 4. Going backwards, I'm going to divide by 4. And, oh no! Dividing fractions! This is awful! Why are you making us do this? It's not that bad. Just going to create some space up here. 5 over 3. Divide by 4. When you see dividing when it comes to fractions, remember, flip the SIP. Which means I'm going to change this to multiplication. 4 over 1 becomes 1 over 4. Just multiply straight across, and I get 5 over 12. I'm squeezing that in right here. So I got an initial value of 5 over 12. Alright, now how am I changing? What's my change going on here? Multiplying by 4. And let's see. It's geometric, exponential, because we're getting to the next value by multiplying, which means I need my variable, or my input, is going to be my exponent. So, got myself a nice explicit formula, or an explicit function. So there you go, guys. That's how you can get from a recursive formula to an explicit formula. Again, you guys have the tools to do this. You've been doing some great work over the past couple weeks. All we're doing is we're taking these pieces and we're putting them together. Hope this helps.